in a sentence, right? So as I introduce myself, I'm Chaitanya. I've been doing threat modeling for a while. Coffee enthusiast. So you all know I can easily be bribed for a good coffee. We have a lot of things to cover. So the agenda is straightforward. We'll talk about what is threat modeling, some frameworks available in the industry, widely used frameworks, and how are they relevant. And then we'll slowly move on to introducing a new way of doing a threat modeling. So what is threat modeling? Why do we need threat modeling? I know we have a lot of experts in the room, so I won't spend much time with this one. So threat modeling is an art. Is an art of foreseeing threats in a lot early stages. Of course, conditions apply. You need to have the right security mindset to foresee those threats. But if you are able to do that, you save a lot of money, resources for your organization. So why do we need it? For this, we have to go back in time and discuss with you when the SDLC came into picture. We all knew software development lifecycle somewhat looked like this at a very high level. It was divided into 5 different stages. Security used to come in the end. And then we thought, why don't we embed into the software development lifecycle in an early stage? And there came the secure SDLC. We decided to sit with the developers and the architectures right in the early stage. We used to provide security guidelines and requirements in the requirement phase. In designing, we started doing threat modeling with them. In coding phase, we started doing static code analysis and open source analysis with them. In testing, we started doing dynamic code analysis and pen testing. And finally, once the code is deployed, our job is not done there. We still do vulnerability scanning and pen testing program onto our applications. Then came the new era of Agile. What is Agile? An iterative circular approach that the software development team started applying. Security said we want to embed into that. So what we did, we took the first and last ends of our SSDLC, merged them together, and we created something like this. And we call it Agile. Technically, it's not Agile, right? There are a lot of problems with this approach, and we'll talk about it in our subsequent slides. But coming back to our presentation, which is about threat modeling. So I'll come back to threat modeling. There are a lot of industry-wide used frameworks. If I'm not wrong, my knowledge says there are around 11 frameworks in the industry. Each and every organization uses different frameworks. We'll talk about some of the very commonly used frameworks. And to start with, our own very favorite, one of the oldest threat modeling framework, Stride. The name came as an acronym for the 6 threat categories that were created, right? As the name suggests, as you can see, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. Combined together became Stride. A lot of teams, a lot of organizations have been using them. Then came the era of Dread. Again, a cool acronym based out of the five categories of risk. But again, the Dread was more focused on the risk analysis and less on the threat actors. A lot of organizations still today use a combination of Stride and Dread, where Stride is used to identify the threats and Dread is used to evaluate the risk associated with those threats. So the combination goes well. And then came PASTA, really cool acronym. Stands for Process for Attack Simulation and Threat Analysis. PASTA is a 7-step approach for risk evaluation and threat modeling for this. Some people say it is attacker-centric. Some people believe it's risk-centric. There's a debate which will keep on going, but we are not here for that. So these frameworks, which are always available in the market, you guys must be wondering, what is good for me? What should I use? Here comes a $1 million question. How relevant are they? Are they relevant in today's world? We have threat landscapes changing every day. We have attack scenarios changing every day. We are in the world where bot attacks are slowly rising. We are in the world where we slowly started seeing how powerful JavaScript is becoming, and that is leading to attacks like MageCard. Companies like British Airways had to pay $1 million because of the MageCard attack. If you guys are not aware, MageCard is a newly introduced way where a JavaScript, an externally loaded JavaScript on your page, can start skimming your payment card information from the page. These kind of attacks, when they start coming into the market, my question to you is, does your existing threat modeling framework, let it be Stride, Pasta, OWASP, any threat modeling framework, can it actually address these new concerns, new security threats that are coming in? Can it scale? You have 1,000+ requests coming for threat modeling for your organization. Does your current threat modeling framework able to scale those 1,000 requests? Can it blend in well with your agile environment? When we read in the theories, these are excellent. These are marvelous. But when I try to implement them in real life, the story is different. It is not purely agile. It's not helping me keep a track of 1,000+ threat modeling requests that I get in an organization such as eBay. So how do we deal with this situation? How do we tackle this problem? And there comes a new threat modeling approach, which is based on OWASP. I didn't give him any cool acronyms because this is not another framework that I want to add to the industry. I don't want to come up with a 12th framework and tomorrow some other Chaitanya Bhatt standing here will be introducing 13th framework. We don't want to do that. What we want is a mindset. What we want is an approach. If there are 60 people sitting in the room, they all should be going back to their organization and creating a threat modeling framework for yourself, for your own organization. So what we are trying to discuss here, what we are aiming here is to talk about the approach. What approach suits well for your organization? So let's start. The basic building block for this approach is a 3-step approach. You have your InfoSec policy. Each and every organization has your own InfoSec policy. These InfoSec policies differ from company to company. An InfoSec policy for an e-commerce company will be different from from a manufacturing company, right? So the foundation of this approach is based on solely your InfoSec policy. Once you have your InfoSec policy, this is where the threat modelers, the security engineers come into the play and start creating the security standards. These security standards are nothing but what should be required to achieve those InfoSec policies. These are all based on OWASP top 10 mitigations, not attacks. Rather than focusing on attacks, the security standards that security team has to create must be focused on the mitigations. That is how you connect to the developers. So once you have your policy, you create your standards. What's the last step? Your controls. Your controls are nothing but the recommendations. These recommendations will help you achieve those standards. And these controls can be strict, can be lenient, based on how critical the flow is. So we are not pushing you into a box of list of controls that this is what you have to do. No. This is your security mindset that lets you believe, that lets you take a decision on what kind of security controls you're going to take. To make this more simple, let's take an example. Your organization, this is a very common policy that each organization has, which is access control policy. So if you have access control policy, in order to achieve that, let's say a team of security engineers come up with a standard called authorization. Straightforward, simple. Now when an application comes for a review, my control for that can be some strict scopes, least privilege access, revoking the access after usage. Now these can go even more strict. If it's a sign-in flow, I'm going to keep it more strict. If it's a regular backend service flow, I might keep it a little bit liberal, right? So based on how critical or how high the risk an application poses, I can keep changing my controls in order to accommodate that. So in order to proceed with this presentation, I took the liberty of coming up with 13 security standards, which are very generic. You all can utilize it. You might add some new based on your organization. You might remove few if they're not relevant in your organization, but these are a very generic security standards that I came up with. Now, as you can see, these security standards will cover all the OWASP top 10 vulnerabilities, but you won't see any XSS or CSRF on it. So if there is an XSS bug, you would go and recommend your developers to implement input validation and manipulation, right? Which covers all the input sanitization related controls. If you want to create a defense in depth, you would go in and recommend your users to implement CSP policies. How do you do that? Browser security will take care of it. Browser security contains all the controls that includes the security provided by browsers. All you have to do is just go in there and enable those functionalities. CSP is one such example. Sub-resource integrity check. If you remember, I talked about an attack called MageCard. Now, MageCard is a serious problem. A lot of companies are actually trying to tackle that problem. Well, the solution, one way to fix the problem is sub-resource integrity check. You start adding integrity hashes to your JavaScript. If you want to recommend that, that would fall under browser security, because most of the modern browsers, except I think Safari, do support sub-resource integrity check. All you have to do is just enable that. So these are the kind of recommendations you can use, and these high-level categories, high-level standards would help you achieve that. Anti-automation, the first one, is nothing but a protection against bots. It'll keep a check. It'll kind of put a rate limiter on your pages when someone's trying to do a lot of bot related attacks, keeps on hitting your page again and again, right? There's another category that I have added called business logic abuse. Business logic abuse is kind of a very tricky one, because here is where you have to wear your most pessimist, a security hat, and come up with a lot of what if scenarios. What if I try to do this? What if I try to bypass this? And you come up with some business logic abuse cases, because a lot of the attacks are not always because of some actual threat present. And many a times it is because an attacker is able to exploit your functionality or create some business logic abuse case. I'll move on to the next ones. I'll just give a quick brief one-liners about each of them. There is compliance, right? With the introduction of GDPR, California Privacy Act, a lot of things have been coming in, and that's where I think security has to step up our game, come up with the compliance requirements too, whenever they are needed. And also, if you have your internal compliance requirements in your organization, such as a service has to pass some of the tests, you can of course recommend everything under compliance. Configuration management refers to OWASP top 10 security misconfiguration. This could be misconfigured server, misconfigured certificates, all that falls into that. Cryptographic control, the name suggests, all crypto related stuff has to fall into this. Data management, anything where your database is unable to handle your request properly. Your parameterized queries, these kind of recommendations is what falls into data management. Already talked about input validation. Logging, we all do log. I think we had an excellent session here before where someone was talking about logging stuff, right? But when you log stuff, you have to make sure you don't start logging sensitive information. You don't start logging passwords in your logs, right? So this is a new avenue that you keep on adding to your threat modeling scopes. These were not available. These are not available in our existing frameworks. Known vulnerabilities. Again, a new era where biggest breach happened because someone was using a known vulnerable version of Apache Struts 2 that led to what? SSN from Equifax was breached, right? So these kind of attacks must be addressed in your threat modeling framework. What's the use of the art of foreseeing threats if you cannot actually determine them in an early stage? So using these standards, we'll actually proceed. You must be wondering like, okay, this guy is coming up with a new approach. Is he going to change the process how we do threat modeling? No, we're not changing the process. We still rely on the requirement gathering and onboarding stage. We have identifying and discovering the phase. We decompose the application, which is nothing but a simple divide and conquer. We apply PSC. PSC, again, nothing but our model that I mentioned, policy, standards, control. The acronym for that is PSC, but that's not the name again. And finally, we give out recommendation and balance out the risk. So with this approach, I think we're getting a lot of information, a lot of talking, right? So what we want to do next is we'll try to take an example, one sample use case, and try applying this PSC model onto this. And for the sake of simplicity, I took a library management system as an example, and we'll follow those 5 steps. So to start with, the first step, which was requirement gathering and onboarding. We start gathering the requirement that the library management system, it aims to manage resource, giving access to the users. There are 3 types of actors who are going to access this. There is a regular user, members, and admin. The kind of data that this portal is going to handle is PCI data because it accepts credit card for your membership fees. The portal is internet facing, not intranet facing. So that's a very important information, and you'll get to know the importance of this. The portal is built on Node.js Express framework, HTML5, CSS3, pretty straightforward. And MongoDB is what the default database that the team is planning to use. Step 2, identify and decompose from our flow. So we started identifying what are the flows. We came up with these 3 users where a user who is a non-member might come in, register, pay membership fee, and become a regular user. Once he is a regular user, he can log in, issue book, return book, and renew membership. Similarly, on the admin side, you can manage resources, update payments for late fine, and send reminders. So with that, we have identified the flows. You might already have started identifying some critical flows in these, right? So we start understanding, we start analyzing that. What's the next step? Decompose. For the sake of simplicity, we'll just take the first row for our POC. And this is our favorite. Every threat modeling team loves it. Data flow diagrams, right? We go crazy for data flow diagrams. So we have a clutter here. All I see is clutter. I don't know what's going on with this. Although I made it, but I don't know what's going on. So following the third step of my process, which was decompose. I decompose this and will try to focus on just the login. But since I have to explain this, rather than doing a threat modeling on this clutter, I just did a simplistic job with just creating an architecture diagram, and we'll try to apply PSC model on this one. So the flow still remains the same. You have admin, member, signs in. There's a login service that requests all the parameters. It logs everything, checks for the member status. There are 3 databases in here. The payment DB is in PCI zone, so that's why you might see a red dot there. There is college database, which is in another zone, which actually is responsible for checking if a user is a part of this college or not. And of course, the front one that you see is an internet boundary. So with this, let's start applying the PSC model and see how fun it is. I'll start with the sign-in page. Anti-automation is the first thing that I would like to recommend. My InfoSec policy is for anti-automation. The standard that I applied was AA, that is anti-automation. And the controls that I want to put on this one is limit sign-in attempts. I want to challenge users with CAPTCHA. If you remember, I talked about some recent threats such as bot attacks. This one will help you protect against bots trying to do credential stuffing on your page. You want to make sure these attacks don't happen on your page. So anti-automation is one such control that are going to prevent that. Input validation. Of course, it's going to accept user parameters, username and password. I want to make sure it is sanitized. No funky characters accepted. So an output security output encoding is applied. So, and next, browser policy, where I want to make sure CSP policies are implemented for known scripts. Sub-resource integrity checks are applied if there are any externally hosted JavaScripts on the page, and you keep on adding those. This can go more strict. This can go more lenient on how you feel, what your security mindset is. Next is log. Of course, you don't want to log any sensitive information, but if you do, you have to make sure you mask it, right? You want to log all the sign-in attempts that have been made just for your auditing purpose, and so on and so forth. I'll just quickly add rest of the components, all the rest of the standards, and it would look something like this, right? Where you'll see login service. I've added known vulnerability KV here because I realize it's being built on Node.js Express framework, and I want to make sure I let the team know to start using 10.15 and not anything before that, because there are known vulnerabilities for all the previous versions of Node.js. I want to get those things right now to the team so that they don't have to refactor the whole code by including new frameworks or have to upgrade it to the new framework, right? There is configuration management that I've added in just to make sure the HTTPS certificates are rightly configured. So all those things are actually, this is how they are being applied in here. So we have applied our PSC model. That was step 4. Step 5, risk. The most important part when you want to communicate this to the developers, how critical it is. Now, for an organization which is newly introducing threat modeling into their framework, into their SDLC pipeline, can actually start with something like this, which is an OWASP-based risk rating framework. It's a simple combination of likelihood and impact. But if your threat modeling process is mature enough, you might also be using something like DREAD. But the most important question here is this okay? Is this sufficient with the PSC model? Let me ask this question again with an example. Let's take this use case. Sprint 1. First phase, a backend system came in for our design review, which was talking to database. And we realized there's an authorization issue because something in the backend is directly referencing to the database. I felt this should be noted, and I added data management and authorization into it. Based on my risk rating, I felt the risk is high. But that was phase 1. Second sprint, phase 2 of Agile. Now, there is a front-end system which is going to consume this back-end service. Now, if you think about it, there was already a residual risk of authorization, which was categorized as risk high. This had authorization, and now we have insecure direct object reference in the front end. Do you still feel the risk is high? It is critical. It is critical. And the reason why we could get this is because just by applying that standard box wouldn't have helped us identify or classify this as critical. This would have still been a high risk, because in our security agile world, we don't take the information what we have learned in our previous phase to the next phase. And that is why when we balance the risk, we need an additional column of existing risk. It looks a little bit confusing, but let me explain how this can be read. So, a vulnerability with impact high, with a likelihood medium, but we realize there's an existing risk which was high, becomes a critical bug, is no longer a high or a medium issue. So when you start propagating what you learned in your previous phase into your next phase, you start bumping up those categories and you learn, and that's how you keep changing your balancing the risk phase of, that's the last phase of your threat modeling, right? So with this, we complete all the 5 steps of threat modeling. We have learned how to how to create PSC for your organization. We have learned how you can apply those PSC model. We have learned how you can balance the risk. But let me ask you this. How do you measure your success of your program? Is it going well? Are there things to be changed? As a threat modeling team, if I have to ask you what are the 10 biggest threats your organization have, will you be able to answer that? What are the top 5 products with maximum risk? Will you be able to answer that? How do you prioritize the threat modeling request if your requests are 100 plus or 1000 plus? How do you handle the incremental changes? Some very valid questions. My manager asked me and I didn't have answers. And that's when I came with the last missing piece of this threat modeling. A threat surfing tool is a tool that was created in eBay that we have been working on for a while. And this is what helps me complete the full puzzle of threat modeling. This is the answer to all the questions that were asked in the previous slide. So where does this fit in? The threat surfing fits in your first stage, and you'll see another 6th step added to your threat modeling process, which is store and analyze. On your requirement onboarding and gathering phase, threat surfing would ask you some basic questions just to understand how critical the project is, just to understand what is the priority of this project. And once it determines the risk associated, how critical the project is, it actually passes on, it prioritizes these applications. And at the end of threat modeling, you basically store and create a risk analytics dashboard, which can be used by multiple people. So what we did here, if you remember my previous slide, I talked about the Agile problem. We actually didn't solve the Agile problem when we just created a circular process within security. A true Agile can only be achieved when you start creating a feedback model, a feedback that comes back from SAST, a feedback that comes from your DAST, feedback that comes back from pen testing into a threat surfing or threat modeling phase. Your threat modeling should be the brain of your process that can help you identify and foresee these kind of threats and risk associated with your application. So how does the threat surfing architecture looks like? There's an onboarding portal. The teams will be coming in. They'll be answering questions like, what kind of data are you using? Can you give out some data elements, what you're using? What's the development language you are planning to build this on? What are the upstream services that you're going to consume? What are the downstream services associated with this application? After answering these questions, this is all fed into our database. And this database is also plugged to our ticketing system. Now, this ticketing system is nothing but the feedback that I showed in the previous slide. It actually pulls data from your SAST, pulls data from your DAST, pulls data from pen testing and everything. It can have all the data associated with an application which are open, which were previously reported. That's how you know what are the residual risks. Combining that with the PSC model is fed into the threat modeling engine, and that gives out your threat modeling portal. Your engineers can log in. They can see what is the queue that I have, what are the previous risks that are available with this request. They already have a pre-filled information that helps them analyze and get some easy understanding right into the early stage to know this could be a big project that could possess some big risks, right? Your security auditors can log into this portal and see top 5 threats in your organization. Which is the biggest risk your application, which is the biggest risk that each application has, which is the most risky application we are trying to handle at this moment. And last but not the least, your executives, your leaders, your CISO can log in to see what is your threat landscape. How does my organization threat landscape looks like? So sadly, I was unable to bring out this tool here because we are still evaluating the legal and privacy aspects of it. But keep an eye on the GitHub eBay page. You should be able to get this tool. We are soon open sourcing it. But if you guys want to build your own, the basic idea still remains the same. So how the tool looks, I was still able to get some screenshots for you guys. So we have a chat bot, which is nothing but an onboarding, which is what is required for onboarding. So basically product teams comes in, answer some basic question. The chat bot will ask you some questions, series of questions just to identify what all data elements you're using. What are upstream services, downstream services, PCI data, restricted data, what are the data classifications that you're using? And this, along with PSC model, finally gives me a threat landscape. Yeah. This is what every executive, every leadership wants to know, wants to see. This is what came out from threat surfing that helps me creating the baseline. So the red line that you see is a baseline from previous year, and the blue bar chart that you see is nothing but the risk for this year. How do you read this chart? You can see here the browser security, which was 5% last year. The baseline has increased to 18%. And again, this is based on test data. This is not eBay's threat landscape. So I just wanted to clarify that. So the browser security, slowly we realize that there is an increasing scope. There's an increasing threats associated with browser security. What can I do with this data? 2020, I can plan projects for this, that I have to focus more on browser security. I know 2020, when I train developers, I have to train them on browser security components. Start adding them into your training modules. Start adding them into your requirement documentation. So this is what actually helps you create a feedback loop. You'll slowly start seeing an improvement, like how you saw in crypto. The 9% from last year has gone down to 7% because you actually added some right controls, some right training modules, some right requirement documentation to the developers. And that is how you know that you are actually doing something right in your organization, right? So PSC model and your threat surfing combined will actually give you a lot of benefits. It is agile in true sense. It can easily update. You can easily update your threat modeling cycle. Usually people try to upgrade their process once in 5 years, but this would actually help you changing your threat modeling process every year. You might add new standards. You might remove new standards. As soon as the InfoSec policy changes, you might add the new standards according to your policy, right? It is mitigation centric. That is how you connect to the developers. Rather than throwing stuff like CSRF, SSRF, the developer is going to get scared out of it. Rather, I tell him what to fix. And that is how we connect to the product teams more easily. It actually can handle incremental changes. It is developer friendly. As I mentioned, it aligns well with your organization goals, and it gives you better visibility across the organization. So with that thing, I know there was a lot of information, but I'll quickly summarize it with 4 key takeaways. First, what we learned from this session. A circular process doesn't make stuff agile. You have to always make sure the smaller iterations are created within your process in order to truly accommodate, in order to truly blend into your SSDLC process. Focus on top 10 mitigations. OWASP top 10 is good for us. it might not be relevant for developers, might not be relevant for the product teams. Build your own OWASP top 10 mitigations. Tell them what to fix rather than telling them that you have CSRF in your application. Tell them what should I do. Threat modeling can be the brains of SSDLC process, and that visibility can be achieved by a tool, something like threat surfing, right? It helps you maintaining the record of your residual risk. If you remember during the balancing risk slide, we talked about how you can identify the existing risk. That existing risk, I know the traditional way of threat modeling is we write, I think 40, 50, 60 page worth document and just hand it over to the developer teams. How do we keep track of it? So we need some tools like threat surfing that helps us in creating and maintaining those records. And that is how we'll be able to fit in well with the agile world. We'll be able to identify the residual risk from each and every step. And last, the most important, adapt threat modeling framework which is best suited to your organization, which is good for your customers, rather than following a standard white paper that tells you what kind of threats your organization has. Rather than that, you come up with your own threats. What are the biggest challenges that you are facing? And the PSC model, the PSC approach is flexible. It's not a new way of threat modeling. It just gives you an approach that you all can go back and create your own threat modeling framework in your organization. And that is how you excel in your program. And that is how you can bring out the maximum benefit from it. With that, I'd like to conclude my presentation. Thank you very much. If you have any questions, feel free to shoot me an email, reach out to me. I think we still have a couple of minutes, so I can take some of the questions if you have. Yes. Yes. Correct. No. So, okay. How do you maintain the consistency? Right? Exactly. That's a very valid question. And that is one of the biggest challenges that we have with threat modeling frameworks. We have to have a consistency throughout your threat modeling process. Now, the way we define these standards were all aligned to your InfoSec policies, right? Now, if your InfoSec policy has to have a JavaScript protection with sub-resource integrity check, of course, I agree with your point that some of you might feel that since you're adding an integrity hash to your JavaScript, shouldn't this be a cryptographic control rather than a browser security, right? But when you define your policy, when you're actually creating your standards on top of your policy, this is where you actually define the threats that are actually covered under this, right? So your browser security should be covering MageCart attack. Your browser security should be covering CSP related recommendations, right? And that is how stringent you actually create your standards and your policies and your controls. That is what is going to define how consistent your threat modeling is across. Like you've been doing it for 5 years, you want to make sure the consistency is maintained. And this is how you actually do it right in the early phase when you're actually defining the standards, right? And above all, this is something that is sub-resource integrity check is more like a browser feature that the browser is giving out to you. This is not that the browser is going to hash a JavaScript for you, but no, it's something that hash that you add so that the browser can validate when the JavaScript is loading on the page. The hash matches and boom, it actually loads the page, loads the JavaScript on your page. So that is the whole concept behind the browser security stuff. Okay.
We had at the beginning a really nice list of standards. Do they actually exist, or is this just something that each company should develop?
So these standards are very generic standards. They can be utilized right away. But my recommendation to everyone is to check with your own InfoSec policy. Most of them will align with your InfoSec policy, but there might be, as I mentioned in the beginning, an InfoSec policy for a manufacturing company would be different from an InfoSec policy for an e-commerce company, right? An e-commerce company wants to look more into browser stuff, more into website related stuff, whereas a manufacturing company might have some other InfoSec policy. So the standards that you saw can actually very well apply to most of the organization's InfoSec policy. But if there are any more that these standards haven't been covering, I would recommend you to add or subtract as per your own InfoSec policy. Yeah, exactly. Thank you. Yeah. No, so how you do threat modeling is still the manual process. In my opinion, in my personal opinion, I don't believe that the threat modeling should be automated, because one of the categories that I talked about is the business logic abuse case. Threat modeling team is the one that requires a very maximum amount of security mindset, because you are the ones who are actually foreseeing the threats. I'm not sure we have a sophisticated automation at this place in the industry where actually that can automatically foresee based on some information. So this is just an information. The tool will just give you some prerequisites, some initial prioritization of an application that will just give you how critical this is, how high risk it is. Hey, you are doing this threat modeling, which already has 5 open bugs from the previous cycle. These information is what you're going to have, and that is going to help you when you perform threat modeling. But of course, threat modeling still is a manual process. Yeah, so those things, these things will be available in the tool. So the tool is currently, as you can see in this one, where the PSC model is actually embedded into the engine. So your PSC model, which you create, will be embedded into the engine, and the portal will help you determine where you want to apply browser security, where you want to apply configuration management and stuff. Okay. So I think some of the previous threat modeling projects by OWASP is something like Threat Dragon and stuff, which is more like focused on you performing threat modeling, right? But it actually doesn't give you whole end-to-end process for this. Just the engine, exactly. So the reason why I called it OWASP-based threat modeling is because there's a heavy dependency on OWASP top 10. The mitigations that are provided by OWASP, there is a heavy dependency on the way the risk is actually evaluated, which is also based on OWASP framework. So that is why we came up with OWASP threat modeling approach. But again, this is more like an approach which can be embedded with, I think, if you integrate this with, correct. Correct. No, so I think to answer your question, the best approach would be a combination of Threat Dragon along with this. That could give you the full end-to-end picture, because what this tool doesn't cover is something that Threat Dragon does. So they both complement each other. Okay, thank you.